Hello, students. How are you doing today? I hope you had a good weekend. Okay, today's topic is going to be on derivatives. And as you can see on the whiteboard, the question says, find the coordinates of the stationary points of the curve y equals x cubed minus 6x squared plus 9x plus 1. Okay, we're going to first start by using the general formula to find derivatives. So we make y equals x to the power n. Y equals x to the power n. So we're going to differentiate this expression y equals x to the power n. So dy dx will be equals to n x n minus 1. N minus 1. So this is the general formula to differentiate an expression, an algebraic expression. So in this case, we have y equals, the curve is y equals x cubed minus 6x squared plus 9x plus 1. So here we're going to have dy dx will be equal to 3x squared minus 12x plus 9. So we just differentiated, as you see, the exponent n in the general formula is equal to 3 in the x cubed expression and is equal to 2 in the 6x squared expression. So we multiply the 3 by the coefficient of x cubed, which is 1, and we subtract 1 from the exponent. We subtract 1 from the exponent 3. So we're going to have 2. So that's how we got 3x squared in the expression 3x squared minus 12x plus 9. We do the same to the remaining expressions. So 6x squared becomes 2 times 6, which is 12x. And we subtract 1 from 2, so we get 12x. So the same thing for 9 and 9x and the same thing for 1. So to find the stationary points, dy dx must be equals to 0. Dy dx must be equal to 0. So in this case, we make 3x squared minus 3x squared minus 12x plus 9. 3x squared minus 12x plus 9 should be equals to 0. So we're going to find the factors of this expression. But first of all, we have to divide through by 3 because that's the common denominator here. So we divide through by 3. We're going to have x squared. You're going to have x squared minus 4x plus 3. You're going to have x squared minus 4x plus 3 equals 0. So we're going to find the factors of this expression. So let me write it properly here. It's going to be x squared to get a better, a clearer view. Get x squared minus 4x plus 3 equals 0. So the factors here are 1 and 3. Because we first multiply the coefficient of x squared, which is 1, by the constant 3. You get 3 times 1 is 3. And you find the factors of 3, which is plus or minus 1 and plus or minus 3. So when you add, you want to find two factors like that. When you add them, you get the negative 4 coefficient here. So negative 1 and negative 3 are the best because when you add negative 1 and negative 3, you get negative 4. So we'll put that in parentheses, x minus 1, and x minus 3 equals 0. So now we're going to find the x-coordinate of the stationary points. So the x-coordinate here, we make x minus 1. We're solving for x. X minus 1 equals 0 will be x. We add 1 to both sides of the equation. We're going to have x equals 1. The same way, x minus 3 equals 0. We solve for x. We are just solving for x. So when you add 3 to both sides of the equation, x minus 3, you're going to get x equals 3. So these are the x coordinates of the stationary point. So to find the y coordinates of the stationary point, we substitute x equals to 1 into the curve x cubed minus 6x squared plus 9x plus 1. So you're going to have x cubed will be, we substitute x into x cubed, you're going to have 1 cubed, which is 1 minus 6x squared. 6x squared, 1 will be 1 squared times 6 will be 6. Plus 9 times 1 will be 9. Plus 1. So when you add this, 1 minus 6 is negative 5 plus 9 is 4. 4 plus 1 is 5. So the y coordinate of the stationary point is 5. So now let's find the y coordinate of the stationary point when x equals 3. So y will be equals to 3 cubed is going to be 27 minus 6x squared. X squared here, if x is 3, is going to be 9. X squared, x is 3 is going to be 3 squared is 9. 9 times 6 is 54. Plus 9 times 3 is 27 again. Plus 1. So when you add the 27 plus 27 is 54. 54 minus 54 is 0. 0 plus 1 is 1. So these are the coordinates. The stationary points are 1 and 5. 1 and 5. And 3 and 1. So these are the stationary points. So if you want me to describe the curve starts, since it's x cubed, it starts from the third quadrant, which is the negative x coordinate and negative y coordinate. That's the third quadrant. And the curve starts to increase, and it cuts through 1, which is the y-intercept, cuts through 1, y equals 1, because when x equals 0, you get y equals 1. So the curve cuts through 1 and increases to the local maximum, to the stationary point 1 and 5, where it turns. At that point, the tangent to the curve is a horizontal, which is equal to 0. So the curve begins to decrease to the local minimum at 3, 1. When it decreases, you have a negative slope. The tangent is a line which is a negative slope. The tangent to the curve is a line where we have the slope as negative. So it goes down, it descends, the curve descends to 3, 1, which is a local minimum. And from there, it turns again. And at the local minimum, the horizontal, you have a horizontal, another tangent, which is a horizontal with a slope equals 0. So it increases, it turns and increases again to a positive slope. So that's how you find the coordinates of the stationary points of the curve. Let me know if you have any questions, or you want to know why I substitute. Kevin, you want to know why I substituted x equals 1 to find the y coordinate? Yes. Yeah, that's the stationary point of the curve. You know, the stationary points are 1 and 5 and 3 and 1. So I substituted 1 into the curve x cubed minus 6x squared plus 9x plus 1 to get the y coordinate of the stationary point. So I hope that answers your question. Okay, let me know if you have any more questions. So this explains the problem in detail. So finally, the coordinates of the stationary points are 1 and 5 and 3 and 1. Okay, I hope you enjoyed the class and have a good day. Thank you and bye-bye.